Okay. Yeah, actually super surprising that Bart had this speech about strategic investors. Actually, we closed the first closing of our Series B just a few days ago with what we consider a very good strategic investor, the KSB, and many points that Bart mentioned in his speech, I think are implemented in our partnering. Well, we are Ecop, manufacturer of the rotation heat pump. I think everyone is more or less aware what a heat pump does. It takes off heat at a temperature level that cannot be used anymore for processes in industry and is lifted by the use of electricity to temperature levels that can be used again. And the ratio between the thermal output and the electricity plugged in is a famous COP. This is, on the corner, you see how the machine is looking like, and in the middle, how it's working. However, I will not in detail describe how this machine is working. I just want to mention here that's a completely different thermodynamic cycle process than a conventional heat pump is using. This is a pure gas process that does not comprise any phase shift and where the compression and expansion is done by the rotation field that is produced with the rotation of the rotor that you can see here in the middle. More interesting is that we produce in our latest version of this machine the rotor with a technology which is called microchannel diffusion bonding. This is used since decades to produce the best heat exchangers out there in industry, and we use it now to realize our rotor and include the entire thermodynamic cycle process for our heat pump. And this gives us the strong enough rotor to turn it with 3.5 up to 4,000 rounds per minute to realize specs that are really exceptional for a heat pump. I come to this in a second. Before, I want to highlight just briefly how we scale in terms of power. We have the core, what we call the core. It was a 700 kilowatt power. And to go to higher powers, we would combine several cores to a node, which we see very beneficial in terms of redundancy, but also part load behavior. So, the merits of this technology is first, we can realize, because it's a function of the rotation speed, lifts up to 100K. Realizing output temperature of up to 200 degrees C, which is really exceptional, including, of course, steam production and so on. And then, what is even more important, second, realize high lifts with still high COPs. That is what, at the end, drives the business case. If you go to a cascaded system where you have to put in a row 2 machines, then you lose your COP all of a sudden. And third, very important for our clients is that we're using a completely climate-friendly, non-toxic, non-burnable working medium. It's basically a noble gas mixture. This is an A1 security working medium, which is not kind of the ammonia heat pumps and everything, or butan, propan, or whatever kind of stuff. And fourth is it's a very flexible system because we can turn and vary and control the turning speed, and though the lift and can cope with different input temperatures, but also with different output temperatures. And last but not least, it is very silent because it's a constant turning process. And we can cool with this heat pump way better than with a conventional heat pump because we do not take off the heat in an evaporation, but in a glide where the system does not make a phase shift. So how does this translate in use cases? This is here one example that I can give. This is the first commercial project that we have with a new rotor design where we connect the 2 heat pumps with a seasonal storage. It's a water basin, the first one in Germany actually, and where the heat pump is lifting the waste heat of a printing factory at 60 degrees C into the 90 degrees C that is required for the storage. And over the winter, it pumps from the decreasing temperature of the storage into the district heating grid. And this is an example for the flexibility of the heat pump because we do not need a cascade to cope with the 90 in end of summer and with the 30 end of winter. And second, of course, in summer, if electricity is 0, we use the heat, the air as hot source and lift the 100K into the storage with a high lift capability of the heat pump. Another one is a perfect use case where you can demonstrate that the cooling and heating at the same time is really interesting in terms of business cases. This is a data center where you can have a chiller and you can use a heat pump to lift the chiller, the waste heat of the chiller into district heating grid. But what if you just use one machine for chilling and heat production at the same time? Just the very last output of what I wanted to say, you can buy with doing this with additional electricity of 83 kilowatt, 1.3 megawatt at 85 degrees C, which is a business case, I would say. Okay, thanks a lot.
Thanks.